Welcome to No Hive, online learning community from Kerala. Myself Mitra, AI-based personal assistant of Dr. Prem Shankar. Do you think Python is slow? Yes. Python is known for being a slow programming language. Although it's a fact that Python is slower than other languages, there are some ways to speed up our Python code. How? Simple. Optimize your code. If we write code that consumes little memory and storage, not only we'll get the job done, but also make our Python code run faster. In this video, I will discuss fast and also a super fast way to loop in Python. The normal for loop, say we want to sum the numbers from 1 to 100 million. We might never do that, but that big number will help me make my point. A typical approach would be to create a variable total_sum equals 0. Loop through a range and increment the value of total_sum by I on every iteration. This gets the job done. But it takes around 1.06 seconds. Although that doesn't look so slow now. It'll get slower as you add more zeros to the number inside the range. Let's speed this up. A faster way to loop in Python is using built-in functions. In our example, we could replace the for loop with the sum function. This function will sum the values inside the range of numbers. This code takes 0.22 seconds. That's way faster than the previous loop we used. This is why we should choose built-in functions over loops. But there's still room for improvement. A super fast way to loop using NumPy, we can optimize loops by vectorizing operations. This is 1-2 orders of magnitude faster than their pure Python equivalents. Especially in numerical computations, vectorization is something we can get with NumPy. NumPy is a library with efficient data structures designed to hold matrix data. It's primarily written in C. So speed is something you can count on. Let's try using the NumPy methods .sum and array instead of the Python functions. This gets the job done in 0.07 seconds. This is way faster than the previous approaches. This is the reason why you should use vector operations over loops whenever possible. Replace your loop with NumPy built-in functions. So far we've seen a simple application of NumPy. But what if we have not only a for loop, but an if condition and more computations to do? Here's when NumPy clearly outperforms loops. Imagine we have an array of random exam scores, from 1 to 100, and we want to get the average score of those who failed the exam. Score less than 70. Here's how we do this with a for loop. That takes approximately 4.3 seconds. Not bad. But we can get faster results with NumPy. Here's how we do this with NumPy. The code above takes about 0.9 seconds. That's way faster and the code is straightforward. Learning data science with Python? If you enjoy our Python videos and want to learn more from me, then subscribe to our YouTube channel or get my Python course for beginners by joining No Hive online platform.